Okay, my name is Sidney Forsyth. I am the director of the City of Cartersville Water Department. I've been with the city for 27 and a half years, director for about 4 years. I started in drinking water in the Navy and just kept on going to the water department here in Cartersville. I didn't know what I wanted to be when I grew up, so I joined the Navy and I got into nuclear power and submarines. And the best part of my job there was dealing with the water, and not the water I was in, but the water I was treating. It was treated for reactor plant, steam plant, but also for potable water for drinking and consumption that way. And that was the most fascinating part. So once I got out of the Navy, that is the part of my job I wanted to continue to work in. The most interesting thing, like I mentioned during the discussion earlier, was that how little the technology has changed. There have been a lot of advancements in technology, but the drinking water and wastewater treatment systems still remain the same as they began. Since the mid-1870s and 1880s, it really hasn't changed that much.
All right, good afternoon. Welcome to the, what month is this? May Lunch and Learn. We appreciate you coming out this afternoon and joining us. We're looking forward to having our talk this afternoon. I just have two real quick announcements before we get started. Next week will be our evening lecture program on Thursday, May 29th at 7 o'clock. It's not our traditional lecture format. It's going to be a sip and stroll through downtown Cartersville, where you're going to start here at the museum and you're going to go to several places downtown with a guide who's going to tell you stories. And this particular theme for this sip and stroll is moonshine stories. So I encourage you to come out and hear those stories and enjoy several sips and nibbles at various places downtown. Come see. Those tickets, yes, those tickets are available, and they typically do sell out. So if you're interested in that, do come and join us. And you do have to stroll in order to sip. And then finally, our summer camp series season will start in a couple weeks. Our first camp for the summer will be on June 9th through the 13th, and that's going to be our circus-themed camp. So if you've got, what's the age group for that camp, Jordan?
5 to 7.
5 to 7-year-olds, neighbor kids, grandkids, kids you just want to get out of your way for a while, send them to the Bartow History Museum. All right, well, without further ado, we'll get started. Introduce our speaker. Sidney Forsyth is here with us today. He's a native of Bartow County and a 1988 graduate of Collinsville High School in Collinsville, Alabama. He spent 8 years in the U.S. Naval Submarine Service as a nuclear propulsion plant operator, engineering laboratory technician, and a radiological controls supervisor. He's been employed by the City of Cartersville's Water Department for 27 years, with the last 4 as Water Department Director. He has an AAS in Industrial Systems Technology from Chattahoochee Tech and a BS in Environmental Engineering from Kennesaw State University. Sidney is the only operator in Georgia to be awarded both Water Operator of the Year in 2003 and the Wastewater Operator of the Year in 2014. Sidney lives in Adairsville with his wife, Chris, joining us today, where they raised 3 children and now enjoy 5 grandchildren. In their spare time, they enjoy camping, traveling, and teaching Sunday school and working on their property. Please join me in welcoming Sidney Forsyth.
All right, thank you. I've been collecting, I call myself a historical collector because of the junk, and information. But I've been working on this for probably 12 or 13 years, something like that. And I've presented several times over the years, but never to people who can call me out. So you guys being history buffs, you may pick out something in here that I might have missed or collected inappropriately. But anyway, I'm not going to go over myself because Trey already did that. So we'll go ahead and get started. We'll talk about the water, the historical phases of the water system in Cartersville. What I won't get to talk about as much because there are not as many records of the sewer system in Cartersville. I will touch on it and I'll talk some about it, but we just put that stuff in there and it just showed up. not a lot of records on it, but there are some. So without further ado, we'll move along. We'll come back to this picture in a little while, and I'll actually discuss what that picture is. But the water department began, obviously, as most water departments do, out of necessity, but not so much domestic or manufacturing as fire protection, right? We had a lot of wooden structures in town. It wasn't a lot of brick and stone and masonry structures in town. It was wooden. And people were afraid of that because there had been several fires around town. And looking back through newspaper history, you can see different towns that basically burned down because they didn't have a good water supply, water source. And there were a lot of wooden structures in town. So what the city fathers decided to do at that time was look into water sources around here. Obviously, we have the river, and that's the natural location you would want to go to, right? But if you're going to use it for something more than just firefighting, for domestic purposes, then you can't just go to the river. We know that, right? And just start drinking that water. So they look for groundwater. Groundwater being obviously under the ground that you pump up and you know, like a well or a spring. So a location was found at what they call Jones Mill, or what we would nowadays know as the backside of Chemical Products, or Thompson-Weinman Dam right beside that, located a spring there. They called it a spring. Today, we would call that the river coming up the side of the bank, right? But it looked like a spring because it was clean. We use riverbank filtration is what we would call it today. But anyway, it began with a contract between the city and the Jeter and Boardman engineering company of Macon, Georgia. The city contracted with Jeter and Boardman in August 6th of 1888 to build a private waterworks facility company, pipes and pumps on the site of the spring down there. And I try not to bring too many props here, but I do want to show you because this is fascinating to me. I did not know about this contract, but I found it in the meeting minutes of the city of Cartersville's city council meetings. This is from August 2nd of 1887 to February 14th of 1893. And you can see this just sits in the vault over there at City Hall. But on, where's it at? I just wanted to show you. Here we go. This is the contract, written and signed in this book by the alderman and the mayor of the city of Cartersville. So that's how I found out that this existed. And I just wanted to show you one thing. I know this has nothing to do with the water, but it just fascinated me. Look at that calligraphy. Yeah, you see that? We used to know how to write. Oh, it is. It's
definitely really fancy. It's hard to read that kind of cursive writing.
I know.
From way back.
Yeah, when I was doing that research, I went in and actually retyped the contract in my English, and it took weeks just to read and get it on the paper and try and get it right. So I have it in a Word document now, but that's more fun, right? But anyway, that's where the water system started. So what they built, this is a little copy of what I just showed you. August 6th of 1888, they entered into the contract, a 30-year contract. So again, this is a private company coming into Cartersville, building the system. Cartersville had the right to use it, but it did not belong to Cartersville, right? It was a 30-year contract. The Jeter and Boardman would operate it for $2,500 a year. The reason it's $2,500 a year is they installed 50 hydrants, and they charge $50 a year per hydrant to have that system in Cartersville. They built from nothing to an entire water system between March and October of 1889, digging with mules and laying pipe by hand. It was cast iron pipe. right? Put in, the system included the spring, as I mentioned, two 60 horsepower coal-fired boilers, two 700,000 gallon per day, compound duplex steam pumps. They were the Worthington brand, if you're familiar with steam engines and pumps. About 6 miles of pipe, one steel water tank on top of a 70-foot brick tower. And if you know the area, Jones and Stokely Street up there on Summers Hill, the corner right there, I think there's some apartments or housing right there on that corner now. That was the highest point they could get to at the time. All right. And not only that, but it was a high point, and then they built a 70-foot brick tower and put a 100,000 gallon steel tank on top of that. And then, of course, 50 hydrants. These were the Bourbon Copper and Iron Works of Chattanooga, Tennessee, who made these hydrants. We actually have a couple of those over at the water department. I can't bring them with me, but we have a couple of those still, not in service. We can't use those. So. But that is what was installed here. This is not ours, but this is what it looked like. That's the Worthington compound duplex steam powered pumps. This is actually out of a Worthington catalog from 1883, I believe, where I pulled that. And we had two of those. So Mr. Boardman, when he came down, he surveyed the city and he looked at it and said, I want to build a water system for 25,000 people. And then we'll let the city grow to the system. All right. Do you know how many people are in Cartersville now? Less than 25,000. About 24,000. All right. We pump an average of 14.5 million gallons a day. This would do, if you add that up, 1.4 million gallons a day if we ran everything wide open, right? That's 25,000 people. But if you think about it, how many washers, how many dishwashers, how many washing machines, how much indoor plumbing, how many toilets, you know? It just wasn't in the mind then. So we got there. This is not Cartersville. This is the only slide I have, well, other than the pump picture. That's not Cartersville because I can't find a picture of it. But however, this is Americus, Georgia. But that tank was built by the same company in the same year of the same material of the same size as Cartersville's. So Jeter and Boardman built that as a 110,000 gallon tank on top of a 70-foot brick tower in Americus, Georgia. So again, this is not Cartersville, but that's exactly what it looked like.
Is that tower still standing in America?
It does not. It's gone. Yeah.
Is that what the clock tower would have been
In Rome? Yes, ma'am. Yeah. It would have had a steel tank on top of it at the time. And Mr. Schweitzer could probably tell you more about it than I, but anyway, so like I said, Americus, not us, but exactly like it. Back to this same picture that I mentioned here. That actually covers two eras in the water department there. You can see the smokestack in the back and the little house over to the right side. That is where the boiler and the pumps, and then there was a little coal yard behind it. Where this picture was taken from is in the river, evidently. If you were standing in the river and you look to the right, you would see the Thompson-Wyman Dam, right? To the building to the left, we'll get to in a moment, that is the filtration plant that was built there in 1913. I don't know how old this picture is. I think it was in the 20s sometime because that's the time period that I can tell that all the structures still existed, right? So they would use, and as the city developed, they said they would use the spring and the steam power in emergencies. I can't find that it ever was done, but they kept it around. So yeah, we built the system, or they built the system in 1889 as a private system. And then we kind of outgrew the system already. As soon as people started tying on, you know, and you would a regular dwelling, a single family dwelling up to 5 people would pay $12 a year for water. no meter, just $12 a year. If you had an extra person in there, it was $13 a year. For every extra person after 5, you would pay another dollar per year, and you would pay it in advance quarterly. You would divide that up over a quarter, so you'd pay, $3 a quarter for your water. Didn't matter how much you use.
Like we need to bring that back.
Do you know what that is adjusted for inflation?
I do not. I know how much the water rates are today. If you want to count that as inflation, then yeah, they didn't pay at the time. There was a method set up for metering. We did have meters. If you wanted a meter, you could get a meter, or you could just get the flat fee. I don't know why you would choose to get a meter, but I guess some folks did.
$13 in 1890 is $456.
There you go. A question I did not anticipate. So we started to outgrow the system, right? And well, let me back up. Before that, like I said, this is a private company. The city is paying this company $2,500 a year every time they add a hydrant or expand the city. They add more hydrants because they're contracted to not go more than 400 feet between hydrants. So if the city expanded, they had to add line, had to add hydrants. And the city council at the time, and David Archer's not here, so he could explain what I'm about to say, but city council frequently uses this. We are not bound by something that a previous council contracted. They do that a lot, right? This council did that in 1892. They didn't like the deal, right? So they started going back and forth, and I can't find exactly what the argument was, but I can find that firemen refused to put out fires because the city would not pay the waterworks company for use of the hydrants. So the firemen said, we're not going to use those hydrants if you're not going to pay them, so we're not going to put fires out. I guess you could do that. I don't know. We expect a lot more nowadays. Right? But anyway, there was a great big argument. So I just want to show this picture. This I think is one of Trey's pictures. This has almost nothing to do with the water system there, but you can see up here, there's a little hydrant. This is in front of Young Brothers, right? From the railroad. Look it out. See the little hydrant there? Right here. That was not a fire hydrant. It was a watering hydrant, and they also kept the dust down in the streets with it. They would spray the streets down. But hydrant number 1, the contract was written based on flow out of one hydrant, right? It will shoot a stream of water 70 feet in the air and maintain 40 pounds of pressure in the system at all times from the other hydrant. It has a pointer on here, but you can't see it on there, and I can't see it anyway. Right there. There's still a hydrant there. It's not that one. But that location and that elevation is what they based the design of the system on. The tank had to be of such a volume and such a height to provide a stream of water 70 feet out of a hose connected to that hydrant. It's a test hydrant. But the hydrant on the left is just irrigation or street wetting hydrant. All right. So, 1893, the city decided they wanted to or Jeter and Boardman agreed, if you're not going to pay us, we'll sell you the whole system. And there was a vote, a referendum, and it was voted 360 to 2 to purchase the system for $45,000, the whole thing, right? So they issued bonds at 5% interest and a 30-year note to purchase the system for $45,000. So on June 19th, 1893, it became the Cartersville Water Department, which is, you see my logo right there, it says since 1893. The system was built in 1889, but the city didn't take it until 1893. Since then, we've been a water department. Right. Mr. John Weichel, you recognize that name? He was the first, he had my job first. He was the first superintendent of the water system, and he got $50 a month. By the way, the engineer, what they called him, the guy that actually ran the plant, got $65 a month. His employee. But he ran the steam engines and shoveled the coal. So, again, back to outgrowing our system. So by 1910-ish, we were moving more water than we could pump out of that spring. I couldn't keep up with it. So I didn't put it in here, didn't put it in my notes, but they looked all over for additional water supply, right? And about that time is when the world figured out that you could treat river water. And going back, I think probably one of the earliest ones, John, you correct me if I'm wrong, Roberts Filter Manufacturing Company in Darby, Pennsylvania. They were one of the forerunners of designing and building filtration plants. Mr. Roberts actually invented the rock water filter that you could carry around on a cart and run water through it, and it came out clean. Wasn't disinfected, it would just look better. Right? Yeah, he got the chunks out of it. That's really what he did. So the city actually contracted with the Roberts Filter Manufacturing Company in Darby, Pennsylvania, which is right outside Philadelphia, to build a water filtration plant for the city. This was in 1912. We have a set of drawings here. It's fascinating, to me at least, when I started doing this. I found that out, found it in the book there, who we contracted with, and this company still exists. Roberts, you can look them up online, Roberts Filter Manufacturing Company. I think it's Roberts Filter Group now or something like that. It's a family-owned business up there. And I just called them. Hey, you built a water plant for the city of Cartersville in 1913. Do you have anything on that? And the guy sent me 12 drawings. And this is one of them. That is kind of the layout. You see there's a plan view up top and a profile down at the bottom. But you can see to the right over there, that's the Etowah River. Up above it, kind of outlined at the top there, you can see where the old spring was, the circle. That's the old spring. And to the left of that, the outline is where the pumps and the boilers. There's a coal yard right outside of it. So that's the old stuff, 1889. And then the 1912 plant is right in the middle there. And they put an intake down on the river, just a pipe sticking in the river, and pumped it by electricity, right? New thing, right? Into this plant. That plant could treat 1 million gallons per day, right? It had two sand filters, one, what it called there, a subsidence basin or a settling basin, where you coagulate the water, you settle out the dirty stuff, you take the clean water off the top, you filter it through the sand, and you pump it out. But that is the original drawing. That stuff is still there. It's in the trees. You have to dig for it. There may be critters living in it, but it's still there. There's actually a little more than that, and we'll get into that in a second. This is another view. I wanted to show this because this is just kind of a close-up view of the chemical injection. I'm not going to do the whole water treatment thing, but the way you do it is you put aluminum sulfate, or at the time they call it sulfate of alumina, or we call it alum, into the water. It coagulates it and makes the dirt turn into solids. It drops to the bottom by gravity, and then you filter the clean water off the top. And that was it, right? When Roberts Filter Manufacturing, like I said, he just got the dirt out, right? Something that didn't happen until 1908, and Roberts Filter was one of the first ones to get on board. If you'll notice, there are 3 tanks up there, like wooden barrels, right? The two on the right above it, and I know you can't read it because I can't read it, but it says alum. That's the aluminum sulfate. The one to the left, it says hypo. You know what hypo is?
Chlorine.
Chlorine is bleach, right? They had figured out that just getting the dirt out is not good enough, right? People get sick still. So in 1908, Jersey City, New Jersey, America started disinfecting drinking water with chlorine. Right down the river from them, in Philadelphia, Pennsylvania, was a large plant that first started adding chlorine to their water to disinfect it. Sicknesses went down, right? Typhoid kind of went away, and cholera and those waterborne diseases. Right down the road from them, Darby, Pennsylvania, Roberts Filter Manufacturing figured that out. They started sticking it in their plans. First one in Georgia, right there. We were the first ones to disinfect our water in Georgia with that tank. The way it worked is you poured bleach in the top and it dripped through a funnel and went into the water. We don't know how much. It could be a tank a day, it could be a tank a month. It was just chlorine going in the water. Anyway, that was fascinating to me. And I got that right from the designer or design company. Anybody familiar with Sanborn maps? Right? I know Sam is, being a former fireman. These are insurance maps, fire insurance maps, right? And I don't know how old these things go back. They go back a long way. But I pulled these two out because it mentioned everything in the water system. And, the size of the plungers and the size of the steam cylinders for the pumps. And then by 1916, they were already treating water with filtration and disinfection. But of course, fire people don't care about disinfection. They care about pressure and volume, right? So that's what they wanted to know. Over to the right, you get a little bit better picture of this system, right? River's over here, there's a suction in here. We've got the filters, and then it's pumped out. They would also use this spring as a reservoir. They could pull out of that as well. So they continued using both. And actually somewhere in the writings it says we're still using the spring, but we'll use the river in an emergency, even after we have the plant here. So it was hard to give that spring up, I think. If you go out there right now, you can find that spring. There is a circle in the ground. It's like a crop circle out there. And one of the last operators of this plant still worked here when I started. And I trapped him one day and I said, go with me and show me this thing. And he did, and he showed me that circle. I'd never seen it before, but it's still there. So I started digging. I don't know if I was supposed to. But I did read, as this thing was built, it was brick lined around the outside of it. So what I did was I dug up a brick and I kept it in my office. This is out of that spring right there. That was the brick that was laid there in 1889. You can't have that one. So that's just kind of a picture. You can see where the old mill is over to the side and where the dam kind of sticks out there. If you want to see an overhead, this is just from Google Earth. You can see the Thompson-Wyman Dam there to the right in these trees here. That's the water treatment plant as it looks today, although trees probably aren't that thick right now. But yeah, I've crawled all through that thing and it's fascinating. It's amazing how little the technology has changed in water treatment. It works, right? Right, John? Still doing it the same way.
It's cost more.
Yeah. So, okay, where are we at? And then by 1918, we had already destroyed the tank on the hill over here. The old steel riveted tank. We needed a new one. In 1907, we contracted with a I don't know if he was a contractor or a farmer, because he was contracted to work not fewer than 10 mules a day digging a water reservoir on top of Ackerman Hill, which we call Reservoir Hill. Morningside Drive behind the old cable TV place up there on the hill now. I don't know that he ever finished that job. But when we built the treatment plant, we had to have a place to pump the water to. So we contracted with Solomon Norcross to design a 1.1 million gallon open top water storage reservoir, where the water was pumped out of the treatment plant into this reservoir, and then it fed by gravity to the town from there. Again, when I started working here, I went in that reservoir. It was still there. People dump trash in it, but it was there. It only got covered up within the last 15 years, I think, when they put the big cell tower up there on top of that hill. What it looked like at the time was that. That's drinking water. That's not creek water. That's not river water, spring water. That is drinking water. So I don't know what all went into that water before you got it. As you can see how well it's protected. I mean, 6-foot fence. No bird's going to go over that, right? So yeah, state of the art at the time. Dug out by mules, and then concreted with asphalt joints, 1.1 million gallons. All right. Also in this time, again, I'm not going to go too much into it because I don't have a lot of information on it, but we were building a sewer system, right? And the sewer system at the time was pipe it out and dump it in the nearest water, the Etowah River, right? We had 2 outfalls. One was this far from that intake into the Etowah River for the water treatment plant. You could throw a rock from one to the other. It was downstream. Downstream. The other was over actually really close to where we have our sewer outfall now on the 113 bridge at the Etowah River where Pettit Creek goes in. That was our other outfall. So if you were on that side of the courthouse, Bartow Street, all your sewer flowed that way. If you're on this side of the courthouse and Bartow Street, everything went near the water plant.
It was all gravity fed?
All gravity fed. If you couldn't get into the gravity line, you had a septic tank or a cesspool or something. However, in 1902, there was an ordinance passed. If you had a water closet in your house, you did not connect it to the sewer system, you were worked in the city chain gang for 60 days. We liked our chain gangs.
Oh, man.
They were useful. I think there was a fine. You could pay a fine and get out of that, but that was, so. It's still on the books as far as I know, so we're watching. This next picture we were really proud of. This actually hangs in our office now. That is a trencher, right? In 1919, we purchased a trencher and a backfill machine. I don't know where this is. It's somewhere in the city because the old city engineer gave this to us from his great uncle, I think, who had it. But some of you might know Cartersville, and this has nothing to do with the water system other than this picture and a little bit of discussion on it. We were the first in Georgia to have a city manager form of government, right? We had the first city manager in Georgia. His name was Abram Cook. He actually showed up here from Philadelphia and he plumbed the Gold Dome courthouse. He came down here to plumb it. And then for whatever reason, we hired him. He became the utility superintendent in Cartersville and then eventually became the city manager. But the guy on the far left there with the bowler hat, that's Abram Cook. All right. He is proud of his trencher. We paid $9,000 for that thing in 1919. Yeah.
Do you know who built it?
One
of the big companies like Lima?
It was, I actually have it written down.
Oh.
I'm sorry, I won't spend a whole lot of time looking this up. I know where it's at though.
Oh, yeah.
My goodness. Okay. FC Austin Company.
Awesome.
Yeah. So not just the trencher, but we also bought, you see there's a mound of dirt over to the right there. So it's drilling, it's trenching it out, and then there's a little auger to the far side over there, and it's dumping a pile of dirt on the side there. Then you lay your pipe in there, and then somebody's gonna put that dirt back in, right? So what you do is you purchase a $2,500 backfill machine. You go behind it, and you can see it's just a drag line, right? You go along there, and there's a drag bucket over to the right there, and it just drags it back on the hole. So at the same time, in 1919, we bought both of those machines. And you can see in the middle of the picture there with his hand on the boom, very proud of his purchase. That is Abram Cook as well.
That was how big of a line, 12 inches?
That there,
Pretty big line.
yeah, it doesn't say, I don't know, John, it's probably 16 inch, something like that. Probably it looked pretty big. I mean, I know you don't know. I'm just asking,
And that
what
was
does it look
water
like?
or sewer?
It looks like sewer. It looks like concrete pipe. But I don't know. We were handed an envelope of pictures and said, here, I think these are yours.
The picture before had a picture of the pipe, didn't it?
It did. Right there.
That's probably, oh yeah, you can see it down there too, yeah, it's concrete pipe, yeah,
Yeah,
pretty good size,
yeah,
at least, yeah.
yeah,
20 somewhere in there.
yeah. Well, if it's 15, it could have gone on Mission Road over there because we just replaced that. Yeah, yeah, yeah. So again, I'm not sure where this was, what they were putting in there. I just know that we're very proud of their machines. Otherwise, there's no reason for two men to be in suits out there when we're digging ditches, right? And you can see he's still got his suit and his hat there, so he's really proud. Yeah. The next slide, I won't expect you to read that, but essentially this is from 1918. It says they tore down the tank on top of the hill over there. This is from, I think it was retraced in 1932. The original drawing was 1916, I believe. But that is city limits, right? The circle, 1 mile radius around the center of town. And inside that shows the sewers. You can't see them, but what I want to point out there, there's some dots randomly spaced in here. Right in here, they're just like black dots in the street. Flushing manholes. What we would do is run water into a sewer manhole. And if the sewer got clogged, you go into the manhole and you open a valve, connected directly to the drinking water, by the way. And you fill it up. And then it works like a toilet. Flush it out. We had them all over. Up until like 1990, we had them all.
All gravity, no pumps.
All gravity, yes, sir. We try really hard not to pump anything more than we have to in Cartersville. And we are blessed with the topography that we have and the foresight to design systems by gravity. We're really blessed to have that. Not very many systems have as much gravity operated system, both water and sewer. Right. Today, that's where we get our water from. Everybody know that? Right. So back up just a little bit. I skipped a lot of history right there. You notice that? Went from like 1919 to the dam. All right. So that old water plant on the river, we expanded it, doubled in size, went to 2 million gallons a day in 1945. At the same time we started building this dam, 1945, right? What a dam does to drinking water downstream is it makes it very difficult, right? And I won't go into all of it, but it adds a lot of iron and manganese because the water coming out of that dam, other than this picture, normally comes out the bottom of the lake, right? The bottom of the lake is not good water. We don't want that. We attempted, and I wish, no, I don't wish. David Archer was here because he could tell you all about it. We tried to sue the Corps of Engineers saying you damaged our water and, by Rivers and Harbors Act, you are not allowed to hurt drinking water quality. They did, but it took a long time for them to admit it. So what we did, rather than go through a lot of litigation, is they agreed there were sluicing gates on the lake side of the dam. And they said, okay, if you want to hook up to that, we'll sell it to you. Right? So right about, you see where the flagpole is at the top of the dam there? On the lake side, right there, there's a platform. And on that platform are 3 gates. And there are pipes that go down into the lake at 3 different elevations, 15 feet apart. And it pulls water through the dam. And you see the pipe coming out the side of the powerhouse here? Right there. There used to be what's called a Howell-Bunger valve there. And if you've ever seen those on YouTube or something, fascinating. They only use them in dams because they can put a lot of water out through a valve. And there's a stilling well right here, and they would just sluice water out at different elevations. Well, we bought that valve, took it off, and threw it away, and hooked our water pipe to it. Right? Not for free, by the way. We had to finance that for 50 years. We hooked our pipe to it. It's tied to the powerhouse, wraps around, goes in the ground here, goes 2 miles up Altoona Dam Road out to Highway 41 almost into our new drinking water plant built in 1970.
Is that all insulated?
It is not. That is steel pipe just hanging there. But the water never stops moving.
Right.
The picture you're seeing there, the original pipe, you see, over here it looks like 1 pipe. Over here it looks like 2 pipes. That's because it is 2 pipes. There's a 20-inch pipe underneath and behind this, and this is a 48-inch pipe right here.
They don't look that big in the picture.
Yeah. The 20-inch pipe was original in 1970, was installed. The 48-inch pipe was put in 2007.
And it's not metered? You don't have to meter that?
We don't meter it there. We meter it at the treatment plant. So the Corps of Engineers, they would come to the plant once a month and read our meter.
And you have to pay for that?
No,
Oh, okay.
no, we pay a completely different subject and discussion. We pay for storage of water inside the lake, not for volume. So however much we can use out of our storage, we get. And that was just paid off 3 years ago. And now we're about to get some more. But anyway, inside the dam, this was, I think Ava's not here. Ava took this picture a couple of weeks ago. The yellow handle valve on the right there, that's where our water comes from, comes through the dam. That's in the bottom of the powerhouse over there at the bottom of the dam. It comes through that valve. And there's about, I think, 400 turns on that handle to shut that valve. You can see it's got an electric actuator on it, but if we're ever up there operating it, it doesn't work. It's 50 years old. And there's a little bit better picture over to the left. She was on top of the dam showing that's actually a 48-inch pipe along the side of the powerhouse there. And then just a Google Earth picture of where the dam is. Not really sure why I put that in there, but that's there. Everybody here knows where that's at. This you can't see. This is the only picture I have of the old primary wastewater treatment plant. And I'm sorry it's so bright. That's actually what the picture looks like in real life because it's been hanging up and it's faded so much. In 1967, we purchased 48 acres on the west side of town to build a sewer treatment plant. All right. We kind of intercepted where our sewer dumped into the river there. We kind of intercepted it and built a treatment plant there. The only thing we did, though, was screen it and dump it right back in the river. Anything that couldn't go through a screen, we collected that, and then it just went right back in. No other treatment. But that was 1967. And 1973, after 1972, the Clean Water Act was enacted, so we had to start actually cleaning wastewater. So we built what's called a secondary treatment plant. We did biological treatment. Anybody recognize the face on the far left there? That is David Archer. Yeah. And Ed Sildine, the next one over. I think Clyde Charles in the middle there. Anyway, I won't go through all the names. Mr. Dean was still in the council when I started here. And of course, David Archer was at the council meeting last week. So he's still kicking. But that was the opening in 1973 of the secondary treatment at the wastewater plant. This picture was taken in around 1990. That is the wastewater plant. Everybody know where that's at? Over there close to Ladd's, Walnut Grove Road, Zaxby's, Dollar Store over there off of 113, near the Cartersville Middle School, if you're familiar with that area, close to that. Anyway, that's a secondary treatment plant. It treats all the sewage. Again, almost all gravity flows to it. We do have 4 pump stations. 2 of them are in the Waterford and 2 of them are over on Main Street on the other side of the hill over there past Kroger. Otherwise, it's all gravity fed.
Did you call that secondary?
Secondary,
What?
yes, sir.
Where's-
Primary treatment means, just like I said earlier, you screen it,
Oh, okay.
right? Physical cleaning of the water. Secondary treatment, you actually put what we call bugs in there. It's a bacteriological activated sludge is what it's called, treatment. And it actually pulls out stuff that you can't see, right? So that's what the Clean Water Act required us to do. So that's why this plant was expanded as it is. And then, like I mentioned, I'm bouncing back and forth between water and sewer here, but they kind of happen simultaneously. The treatment plant that was built in 1970 actually began operation in 1971. That's this one. This is the drinking water plant on Altoona Dam Road, Highway 41. The road at the bottom is Altoona Dam Road. You go to the right, you'll go all the way to the dam. On the left would be Highway 41. It was built originally as a 3 million gallon per day treatment plant in 1970. Right, so there's not a whole lot going on. Why I don't have a whole lot of information between like 1945 and 1970, because we'd expanded to 2 million gallons per day at the old plant, and we built this one in 1970 as a 3 million gallon per day plant. Not a lot going on, right?
That's still there?
Absolutely.
That still functions?
Oh yeah, every day. We're making it bigger right now.
Oh, that's the one they're adding on to?
That's one of them, yes sir. We're actually both treatment plants right now.
They're adding on to this one.
Yes sir. Let's see. This is a little bit more current view from Logan's drone. I'm sorry, I'm trying to speed up. I know everybody's on a schedule here. But that is a 27 million gallon per day plant. We average, like I said earlier, about 14.5 million gallons per day. 7.5 million gallons of that goes to Bartow County. We sell them that. This is just a SCADA shot of the same thing. We actually control the plant from this screen. This is a shot of our computer screen at the water treatment plant. And you can see during this day, I don't even know what day that was, we were treating 12.1 million gallons per day. All right. So you can see, I'm not going to go all through that. You know, it comes from Lake Altoona, 27 MGD. There's our flows. We store it in, we have 4 storage tanks in town. 3 of them are 5 million gallon tanks, and 1 of them is a 3 million gallon tank. Approximately 230 miles of water mains. And that's the mains in the street, not everything that goes to your house. This is the wastewater plant. That's roughly a today shot. It's a 15 million gallon per day plant. Treats all the sewage from the city, a good bit from the county, and empties it into the Etowah River. Again, another SCADA, what we call SCADA shot. This is off a computer screen where they control that plant. So it's pretty well advanced, and we're making it more advanced day by day. Again, we average about 6.8 million gallons per day. We only have 4 sewer lift stations that are not gravity. And again, 2 of them are in the Waterford, and 2 of them are over on near I-75 on Main Street. 144 miles of sewer mains in the city. Yeah, we're adding to it. If you don't know where my office is, we're now over on Douthat Ferry Road, 301 Douthat Ferry Road, up near the First Baptist Church there. We just moved in there last year. Actually, at our dedication of that was June 19th last year, the birth date of the Cartersville Water Department, and I failed to mention it when we were doing it. So, but yes, that's our new office. And with that, I'm done. Yes, ma'am.
You mentioned that the water piping was cast iron.
Yes,
The sewer piping was concrete.
that's correct.
Are those pipes still under there?
Some of them are.
And you still use them?
Yes, if they're in the ground, we're still using them. Especially if they're right downtown and near the railroad, because we're afraid to touch them.
I bet.
Yeah, I mentioned the different types of pipe. We have some of that old cast iron still in service. If you go down by where old Union Carbide was, right there, the curve at the railroad spur, that line underneath there is still original. And we made a tap on it about 10 years ago, and I got them to bring me the coupon where they drilled the tap into the line. That's it. That is cast iron pipe from 1889. Today we use what's called ductile iron pipe. It looks like this, right? And this has about 3 times more strength than this. All right, so this will yield at about 60,000 pounds of pressure. This will yield at about 20,000 pounds. So it may be heavier and thicker, but it's not stronger.
And I hear you say you use SCADA system to run your system?
That's correct.
You use SCADA?
Yes.
What did
Yeah.
you call that on the pipe?
Ductile iron,
Ductile iron?
DUCTILE, ductile.
Thank you.
Sure, sir.
I got 2 questions. Number 1, what do y'all do with what's left over after everything's done? What do you do with
That's a
that?
good question.
That's question number 1.
Okay.
And this is a question that a lot of people in ag work wants to know. When you got a sewage treatment plant, why is it got to smell so bad around the area of that plant, not just in the plant itself? And can you do something to reduce the smell of that plant? Because the one in ag work down by the Christian school down there, in the morning sometimes you can hardly drive through that. I mean, I know you don't have nothing to do with that,
Yeah.
but there got to be a reason for that, and there got to be a solution to it.
Well, it is what it is. That's always been our standard answer. Until people stop flushing, we can't stop it from stinking. However,
Right,
this is 2025.
thank you.
There are things that can be done. There are odor control systems. I can name 3 or 4 different plants in the metro area that have those odor control systems. As a matter of fact, we're about to expand our wastewater plant, and part of it is going right behind our office.
Yes, sir.
I'm putting odor control on it, right? There are various reasons that it would smell. Sometimes, and I hate to admit this, sometimes if you drive downtown right at the railroad, right in front of Young Brothers, every once in a while you can smell something there. And it's a couple of industries downtown, and what they do is they'll dump a lot of stuff all at one time, and they'll fill those pipes up, and the gases will come out the top, and you go like, oh, what is that? They shouldn't do that. But the treatment plant itself, there are odor control measures. They're very expensive, very, very expensive. Fulton County has a couple of the Johns Creek environmental campus, they call it. It's a wastewater treatment plant. They call it environmental campus because you can't see any water there. Everything's covered. And everything is odor controlled, and they blow it through carbon filter stacks before they discharge the air out. And it's very, very expensive to install, and very expensive to operate, but it can be done. It just depends on how much money you want to spend to make that problem go away.
Maybe you might make one phone call down to ag work. You got a solution to the problem. And,
I don't have a solution for their funding. But your first question you asked, what do we do with everything after? That's called biosolids. It's a Play-Doh-like substance. We, the city of Cartersville, land applies it. We have tractors, we have dump trucks, we have spreaders and loaders. We carry it out to a few private farms and spread it on their property if they allow us. And then the city itself actually owns 500 acres. Owns a 500-acre farm where we spread it ourselves, and we actually own it and maintain it ourselves.
And they don't want to sell it to make no orgonite anymore, or is it?
You can't. We can't. There are 2 different types of biosolids. There's a Class A and a Class B. Class B is what we have. It meets certain standards where you can land apply it as long as you're not grazing it, no food crops, it's not near a water body, those kind of things. Class A you can sell it and you can market it. We don't yet have a Class A. I'm working on it. It's coming. But as long as I'm here, we're not going to sell it. I don't intend to sell that product.
And do you guys still use A, B, and C operators, or is that a thing that's gone by the?
1, 2, and 3.
Oh, it's called 1, 2, and 3.
1, 2, and
Not
3.
A, B, and C anymore?
Right.
On the biosolids, some has to be injected and some is surface applied. You said you can't graze it or anything like that. For how long?
Oh, on the biosolids? I think the affidavit that we make them sign is they can't have any grazing animals on it for 30 days after we land apply. Now, our biosolids have to meet in certain standards before we can put it out there. It can't draw flies, it can't smell, it can't have any what we call vectors. No buzzards can land on it, right? It can't draw anything in there. If it does, we're not meeting the standard. But 30 days, yes, sir.
You deal with the high metals levels it is in.
We monitor it. If the metal, our lab director is right there in the corner. She is the one that monitors all that, and we know exactly what's going in there. There's a massive report that we have to generate every year, actually 2 reports at the same time every year with all that in, nutrients, metals, bacteria, everything.
What are you having to do now about all this that's come up about plastics? Have you got more?
Are you talking about the PFAS? Or microplastics? They're 2 different things. Microplastics are something you could probably still see mostly, something that could, cause a problem. We do have something we installed 4 years ago. As we actually, you asked earlier about primary and secondary treatment in the wastewater. Primary is screening. Secondary is a bacteriological treatment. Now there's what's called a tertiary treatment, which is actually a physical barrier between this secondary treatment and the river. It's a filter. So all of ours is actually filtered now. So we're capturing as much as we can. The regulations on that are ever changing, and they're not finished yet telling us what we need to do. So I'm not going to do too much before we actually have a rule to follow. Ma'am?
I have 2 questions, and the first one's not intelligent.
Surely.
I'm aware. I majored in history. So I can't do science. Okay, the bleach, how does that go away?
How does it go away?
Or are we drinking that? The one that's cleaning I guess is fine because I'm still here.
Yeah.
So does that just y'all just use a little bit so it's enough to kill off the dirt but not the people?
Yeah, what it is we add enough. We're required to have at your house a 0.2 milligrams per liter, parts per million of free chlorine residual, right? So it's not bleach. It's free chlorine. And if you have a 0.2 parts per million of free, which you don't, you'll have a 1, right? Is what we try to go by, 1 milligram per liter of chlorine, which ensures that it continues to disinfect into the distribution system all the way to your house.
I live in Emerson, so I don't know what we're doing. But my second question is, do y'all have beef with Bartow County's water department? Or do y'all just share the water?
Do we have beef with them?
Well, I just think that'd be a cool story.
We started supplying them in 1969. Was the original, actually, the man that was in the room when the Bartow County water system started. It was right there.
Sorry.
He doesn't work for Bartow County. He's a private engineer, so he just happens to be involved in all of it. And we have a contract. Right now, we just signed a new contract in 2023. It's a 30-year contract to supply them at least 7.5 million gallons of water a day. They pay for it. But
Under the
I
new
understand.
guidelines for the government now, don't y'all have to take some of the stuff out of the water?
Which stuff is that? We have to take a lot of stuff out of it.
There's been something about Keith or whatever it is.
Oh, Lord. Fluoride.
Fluoride, whatever.
Fluoride. January 1956.
Right.
The city of Cartersville started adding fluoride to our water, drinking water. There was no regulation on it. We weren't required to. As a matter of fact, there was no such thing as a drinking water system permit. All right, we just did it. We have added fluoride to our water every day since. I have my own opinions about it. Everybody has their own opinions about it. It's very expensive, and we can have a larger discussion about the necessity of it. But right now, it is in the city's permit to add fluoride at a certain 0.7 milligrams per liter to the drinking water supply. The only way that gets out is, the only way that's taken out of our permit is that the city of Cartersville has a referendum. They vote on it. The city council says we want it out. They send it to the legislature. The legislature says take it out. The EPD then modifies our permit to take the fluoride out. Then I can turn it off. So it's not up to me. Any other questions? All right. Thank y'all.
Thank you, Sidney. That was fascinating. Appreciate you coming out and doing that. And
Thank you.
We all learned something new. Folks, thank you all for coming out today, and we'll see you again real soon.
All right,